I am a world citizen. If I could have a world passport, I would choose to have a world passport. How did it come to this? It all starts with my father who was obsessed with improvement, with data, with analytics as we would call it this day. And I as a child was mesmerized of what he was doing. To such an effect that essentially I then cut school and started as a lab technician and wanted to experience that. So I was exposed to business from a very early age, which I think has really shaped me. I then went back to university, had a formal education, and I am a chemical engineer by training and had doctorate courses in business administration. I started in the industry. I ran a chemical plant. I know what it is to be on a night shift with operators running a plant and nobody there. And I think that has all shaped me. That has all shaped me because it showed, okay, how important it is to have very good operations, to be respectful with the people who run operations, that you are not always the smartest person in the room, even though you may have the best education of all. And after 10 years in the industry, I had the opportunity to start in a software company. And in that software company, I had a technical job. And that then started something else, okay, that then led to this world citizen that then took me around the world, literally to 8 countries on 3 continents. So at the center of all of this, okay, was always this obsession with data, this obsession with improvement, this obsession with optimization. And that has shaped me and has also given me the opportunity to absorb and to give back a lot of the things that I've seen. I don't know anymore, okay? I cannot remember, okay, how it started to shift, okay, from a very chemical engineering centric thing to a more business application environment. I really do not remember, but it could be that it was the first piece of software that I was really utilizing in the industry. It was a very specific piece of software that did what's called mass and energy balances of chemical processes. And I saw the economic impact that had, and that impressed me. And that really impressed me. And I started to learn that the world is much, much bigger than the small thing that I had studied. And it also opened my eyes to understand what other people were thinking about a specific problem. So it wasn't a small world anymore. Okay? And due to some of our life decisions that my wife and I had, it just started to add one after the other, going from one continent to another, from one country to another, from one city to another, where I just picked up more and more and more of this. I believe, it goes much more beyond the typical view what optimization has, okay, to increase efficiency. I believe it also serves humanity, it serves the planet. It serves quality of life. That's at the center. A lot of things wouldn't exist these days without optimization. prescriptive analytics. So it's this other element that has also driven me, and again, that's possibly another part of my background, due to my family, due to my wife, that not everything is important in life is just business. It is much bigger. But now coming back to optimization from a business perspective, it is definitely an area which allows you to position yourself in a differentiated and unique way. It's creating a unique positioning in the marketplace, in a usually very competitive marketplace. It is putting together everything there is, from data collection to value delivery, and that, I believe, is another key element. It's optimization is the final piece that really delivers value. It's the result of all the steps that come before it that essentially are the necessary steps to generate value. But the delivery of value is definitely optimization. A coincidence. Really a coincidence. I was working for a German Silicon Valley startup that was in the data analytics field for the financial industry. And it got acquired by a very large player, and I really didn't want to go down that route of a large, highly politicized player. And the coincidence wanted it that exactly during these days where these sales happened, I just got in contact with somebody who knew Gurobi Optimization, and literally a couple of weeks later I was in the company. So why was I fascinated, and why am I still fascinated by Gurobi Optimization? Very simple. It is this relentless focus on improvement. It is this relentless focus on improving people's lives. It's this relentless pursuit of value for the people who use optimization. And that has always driven me, and that continues to drive me. And then I have to say also, I was impressed by what the three founders had put together. It's absolutely amazing. A technology that is second to none. It is a very complex piece of software. It is, as one of our founders says, a huge bag of tricks that when it comes together, it allows you to solve problems that had not been solved in the past. What Gurobi Optimization does is essentially to abstract a business problem into mathematical language. It allows you to describe an objective that you want to improve, that you want to maximize, that you want to minimize, with all kinds of restrictions and variables that are necessary, that are the degrees of freedom that you can play with. And very often also with mutually exclusive variables that could one be true and the other false. This is the power of a mathematical optimization, in such a way that you define what we call absolute truths. So things that have to be true. And that allows to model any system, any environment, and this is what we call now a digital twin. So this allows essentially to accompany a system and environment as it evolves over time and adapt to it. That is what Gurobi as a software does. Now underneath, okay, it's called mixed integer programming and linear programming and non-convex and convex, all these mathematical terms. But essentially it is a faithful description of what you want to optimize. And that is a very unique feature of this optimization technology. One of our founders says that Gurobi is a huge bag of tricks, and I think this is one of the key innovations. So how to put together all these tricks in the sense that they play together and that they help to achieve this outcome. This is one thing. That has led to unprecedented improvements from an algorithm and from a solution perspective. When you look at the problem that was solved in 1991 with a speed of 1, it's now solved with a speed of 3.3 billion. The increase has been astounding. This has been an increase in algorithms, this has been an increase in hardware, and this has allowed, particularly over the last few years, to solve problems in terms of complexity, in terms of size, that were essentially intractable 10 years ago, even 5 years ago. Some of the most notable improvements are areas that allow to mimic also the human mind, how it works. So one is hierarchical optimization. We tend to think, what is most important? What is next important? What is next important? This can be modeled in the software exactly the way a human mind would work. Another aspect that we are right now exploring heavily is how to integrate machine learning models with optimization models. So machine learning models essentially take data, apply a statistical method to come to an outcome, a result of what those data represent. That machine learning model can now be integrated into the software and essentially optimized. And that is a powerful innovation. So integrating machine learning with optimization. The third element that we are now working on heavily is nonlinear processes. Unfortunately, the world is not linear. In many ways, it is deeply nonlinear, and the way we have dealt with those problems has been not very elegant. It worked, but has not been very elegant. With the nonlinear capability that now Gurobi has, we can model that in a native way and find that proven optimal point, which can be an enormous competitive advantage. Mathematical optimization is a digital twin technology. What is that? It is essentially a faithful representation of the physical world in mathematical language. And what is very, very important here is the definition of truths which make up that physical world and the causal relationships there are between those elements in the physical world. All of that can be coded with mathematical optimization. And that's why it makes it so powerful. Artificial intelligence is a term that goes back to the 1950s. Optimization is a term that goes back even further. In the 1950s, a lot of optimization problems were then actually deemed artificial intelligence. So it's a concept that is very, very old. What artificial intelligence is today is usually utilized in the concept of manipulation and usage of massive amounts of data with some mathematical algorithms that then allow to extract some important findings out of those data. And here is one of the fundamental elements, why also I find optimization so attractive. When you have data, you inevitably will look always into the past. These data were collected in the past. And when you're utilizing those past data to infer the future, you implicitly always assume that the future is going to be the same as the past. And you also implicitly assume that everything that there is to know about the system where you extracted the data from is in those data. So any changes that could happen to that system in the future is not coded in any form or shape in those data. That is one of the major issues of any problems that are purely data-driven. Many of the artificial intelligence technologies utilized, the machine learning technologies utilized, depend exactly on that basic principle. You have historical data, and your premise is that all there is to know for the future is in those data, and that assumption is likely incorrect. Here is the difference to mathematical optimization, because you do not rely heavily on the data. You rely on the data to configure the model, and you can utilize the most recent data in your optimization model, because that optimization model again is a faithful representation of your system as a digital twin. So any prediction that happens into the future is based on that representation of that system as well as the most recent data. And it allows to be very flexible and adjust to any changes. You do not have to rely on a lot of historical information. That is, I would say, one of the key differences between what optimization is and what the general field of artificial intelligence. That's one point. The other point I'd say is a lot of artificial intelligence applications are black box models. You do not really know what happens inside that model. Something comes out. Explainability is rather low. Transparency is rather low. And that leads to some trust issues. Trust issues, why should we trust the outcome? Optimization attempts to solve exactly these problems, that the model should be explainable, should be white box models. The model should be transparent and hence should essentially create much more trust in utilizing this type of approach than classical artificial intelligence. Now, mind you, there are many applications where this purely data-driven approach works perfectly well and is extremely well suited, and where optimization couldn't help at all. Yeah? One example I always like to utilize in this context is the game of chess. The game of chess is always a board 8x8 with 16 pieces in white, 16 pieces in black, and the rules are known. The rules do not change. The pieces do not change. The board doesn't change. So all the data you calculate or all the data you collect of all the chess games are a very good representation of any future chess game. So this heavily data-driven artificial intelligence approach is extremely powerful, and it has proven that for the last 30 years, every single machine has outperformed the best human player. Yeah? But in many situations, that's not the case. Okay? The rules change, the environment changes. So how do you codify all of this? And data alone cannot solve this. This is where, again, optimization as a digital twin technology comes in. At the core is, what I call the translator problem. The translator problem is nothing else that you have here a group of people who are specialized in utilizing data, in utilizing algorithms, in utilizing the language of mathematics, and that models a business environment. And then there are people who are deeply exposed to that business environment and need to solve business problems, need to improve KPIs, need to resolve daily issues. The two worlds are extremely apart. And how do you bridge them? This is what I call exactly the translator. So one of the key issues I do believe now these days is exactly that missing role of a translator. That missing role that bridges those two worlds. If that is resolved, I believe, this is going to take off even more than it already has. It has become better. It has definitely become better, but there is still a lot of work to do. The other issue is this notion of do nothing. Do nothing is the simplest answer, and particularly in situation where you try to introduce a new technology in order to solve a business problem. You hear very often, we tried this 5 years ago, we tried this 10 years ago, and it didn't work. And this is an answer that is very dangerous, because then a company becomes driven. It doesn't drive, it becomes driven. Because there will be people, your competitors, who will do something, who will start a project that improves, and your competitiveness will suffer. So this notion to overcome this do nothing is one of the big challenges. technologies are advancing at a light speed. What wasn't feasible 5 years ago, now all of a sudden is feasible. What we deem intractable now, in the near future, it's going to be tractable. What happens more and more and more is that your space of optimization gets bigger and bigger and bigger. You involve more and more decision points. You integrate more and more areas into this single optimization solution, which means it gets closer to this holy grail of end-to-end optimization. That's one aspect. The other aspect is powerful computing. It's just amazing what is now possible. Here is an example. A problem was intractable in 1989. In 1999, it was solved for the first time in 23 minutes. The same problem today is solved in 5 seconds. When you look then at other algorithms improvements, you see a speed improvement of 3.3 billion. So you can now solve problems that are meaningful and that really define the competitive advantage of a company. And this is going to continue. So ever more bigger problems, more complex problems. The other element is speed to decision. I remember the time when I was in the industry, we uploaded a problem in the evening and hoped to receive an answer in the morning, and we're happy. That time of decision making, of obtaining a result has been cut more and more and more. And we are at the cusp in many cases of almost real-time optimization. In the financial industry, portfolio optimization is now essentially real-time optimization. It happens instantaneously in milliseconds. Order confirmation for e-commerce, behind it is a very complex optimization model. It now happens in less than a second. So more and more processes that are intrinsically complex can be solved in very, very short periods of times. Complexity. This is another key element I believe optimization can help. We are facing a world that is ever more complex, and that leads to less and less productivity growth. So more complexity means less productivity growth. Optimization has the power of defining a future that could be simpler. So optimization is not just to solve a problem that exists today to fight the symptoms, but to envisage a future that is potentially simpler. And as Steve Jobs once famously said, simplification is the ultimate sophistication. And that is, I guess, the path that we can take optimization to. I've also been interested in optimization because, again, it goes way beyond the improvement of business processes and extracting economic value. It has a real impact on people's lives and quality of life. Calculate the optimal location of healthcare facilities in a poor country. A real project that has happened with a company that we work with, that's Analytic for a Better World in Timor-Leste, has done exactly that. So they are now building healthcare facilities where everybody in that country has access to a healthcare facility in a radius of 5 kilometers. In Nepal, the test locations for COVID, exactly the same problem. So optimization has the power to improve people's lives and has the power to improve our quality of life. We love to order a pizza in the evening and to say, please deliver it at 7 p.m. and it should be hot. And guess what? It arrives at 7 p.m. and is hot. This is all the result of an optimization model running in the background. And it improves our quality of life. We do what we want to do at the time we want to do it. So optimization is a much more holistic concept than just utilizing it for business benefits. And that certainly has also drawn me to it. We all face macro trends that we cannot avoid. There are many macro trends of which some are relevant to Gurobi, relevant to optimization. One clearly is environment, decarbonization. How do you drive CO2 reduction? Massive problem with a lot of applications. Investment applications. Which investment path is the best? Electrical distribution in such a new world. How do you store electricity and sell it or buy it in such a new world? These are all massive optimization problems that clearly are going to drive our future, because we don't have any other choice. We need to solve this climate change problem in one or the other way, and technology and optimization can help. A solid education of mathematics is key. You can take this out of books. This is necessary, but it's not sufficient. I would say to all young people, go into the trenches. Go into the places where you really see how the world functions. Experience yourself operating something. This will give you a much broader understanding of what this powerful language of mathematics can do, and the appreciation of other people who don't have that background. So I would say having a solid education, either engineering, pure mathematics, physics, is absolutely key. But venturing out and going to the world of the people who do not utilize that language, but who have to run a business day to day, run an operation day to day, work in a manufacturing environment day to day, will give you a much broader background and appreciation of what they need and what you could offer. That has been my own learning. That has been exactly my learning. When I was running a chemical plant, that was exactly the appreciation that I gained. Of all the people who tried to make the best that this chemical plant functions safely and effectively. None of these people had a mathematical education, but they were acutely aware what had to be done that this operation is safe. I'd say I've never learned more in my life than during those years I was having that job. And it gave me exactly that appreciation how to combine this knowledge of mathematics, this knowledge of engineering with this other knowledge of a business environment. That's something I'd say to every young person, do that, okay, and you will never regret it. The power of transformation. Optimization has the power of transformation. And that is, I believe, in today's world of disruption, the main point. The times where the world was linear, there was an input, there was a process, there was an output, those times are gone. They existed in the 80s and 90s. Disruption has become the norm. And for companies to thrive, they have to be comfortable with this disruption environment, which means a company has to transform. Optimization has the power to support that transformation. And an optimization is not that mystic thing. It delivers real business value. It delivers meaningful change that benefits everybody in the company.